What if the loudest signal from an alien civilization is already crossing space right now, sent by a species that went extinct 10,000 years ago? That single idea might be the real answer to a question people ask on almost every clear night. If the galaxy is this big, where is everybody? The honest answer might have nothing to do with how many aliens exist, and everything to do with whether meeting one is even possible, which may depend on something rarer than intelligence itself: perfect timing. This video is about why timing, more than distance or technology, could be the real reason space has stayed quiet. Two civilizations don't just need to exist somewhere in the same galaxy, they need to exist during the same narrow slice of cosmic history, notice each other, understand what they're seeing, and stay alive long enough for a reply to arrive. Miss any one of those conditions, and a galaxy packed with life can look, from Earth, exactly like an empty one. So before picturing spaceships or alien ambassadors, picture something far less cinematic: a radio wave, decades or centuries old, sweeping past Earth right now while our telescopes happen to be pointed somewhere else. That one missed moment might be the closest first contact ever gets. We tend to imagine first contact as a meeting between two living worlds, ships arriving, messages exchanged, questions answered within a single human lifetime. The universe doesn't build its clock around human patience. Stars ignite at different ages, planets cool and settle on their own separate schedules, and evolution never checks in with a shared calendar. One planet could already be growing cities while a neighbor a few hundred light years away is still cooling down from its own formation. By the time that second world finally produces something like a civilization, the first one may already be gone, buried under its own ruins. So the real question stops being whether aliens exist somewhere in the Milky Way, and becomes something narrower: whether their existence ever lines up with ours in time. That question matters more than it used to because planets themselves have turned out to be common rather than rare. Astronomers have confirmed more than 5,000 worlds beyond our solar system, with thousands more waiting on verification, and the numbers keep pointing toward a Milky Way that holds more planets than stars. Even the nearest known exoplanet sits roughly 4 light-years away, already farther than anything humans could visit within a single lifetime. Scattered across that ocean of worlds, some almost certainly carry oceans, atmospheres, and chemistry that would have looked familiar to a young Earth. None of that proves anyone actually lives there. A planet can sit at exactly the right temperature for billions of years and stay completely sterile because nobody fully understands how non-living chemistry first crossed the line into something alive. Not even the scientists studying our own planet's history. That first spark might happen easily wherever the ingredients are right, or it might be closer to Earth winning a lottery so improbable it hasn't repeated anywhere else. Even if simple life turns out to be common, intelligence is a completely separate gamble. Earth spent most of its 4.5 billion year history run entirely by microscopic organisms, with complex cells taking an almost unreasonable amount of time to show up at all. Multicellular bodies came later still, followed eventually by nervous systems, tool use, language, and the kind of curiosity that finally points a telescope at the sky. Every one of those steps depended on the last one surviving mass extinctions, climate collapses, and plain evolutionary luck. Dinosaurs had well over 100 million years on this planet and never built a single radio telescope. Whatever we call intelligence might not be evolution's finish line at all. Just one strange, rare branch among millions of outcomes that never needed to think their way into space. And yet the sheer size of the galaxy makes total loneliness feel almost unreasonable. Billions of stars burned for billions of years before our own sun even formed, meaning some civilizations, if they exist, could have had an enormous head start on us. That thought is close to what struck the physicist Enrico Fermi during a lunchtime conversation in 1950, when he reportedly looked up and asked a simple, unsettling question: if intelligent life is common, where is everybody? His question never proved that advanced aliens should exist. It just exposed an uncomfortable gap between a galaxy full of opportunity and our complete lack of confirmed contact. No verified signal has arrived, no unrecognized machine has entered our solar system, and no distant structure has ever been confirmed as someone else's engineering. Researchers are quick to point out that this proves very little, since looking through one small window and seeing nothing is not the same as knowing the forest outside is empty. Humanity has only been capable of listening for artificial signals for a handful of generations, covering a narrow slice of the radio spectrum and a tiny fraction of the sky. Modern radio astronomy has existed for barely a moment on the scale of the universe, which means an entire civilization could have risen and vanished millions of years outside that narrow window without us ever noticing. To see why that matters, imagine a technological species living 10,000 light-years away, watching Earth right now through its own telescopes. Everything they'd see happened 10,000 years ago. A planet with no cities, no electricity, and no radio, biologically alive but technologically silent. Meanwhile, we'd be staring at their world exactly as it looked 10,000 years before we ever pointed a telescope in their direction. Neither side would have any real idea what the other had since become. That's because space never shows us the universe as it actually is right now. Every telescope, without exception, is really a machine for looking backward through time. Even sunlight needs about 8 minutes to cross the gap between the sun and Earth, and light from farther stars can spend years or centuries making that same trip. A signal sent from the far side of the Milky Way could spend tens of thousands of years crossing the space between there and here, and relativity won't let anything, light, radio, or otherwise, shorten that travel time. Which means an interstellar conversation, even under perfect conditions, would move at a genuinely brutal pace. A civilization just 100 light-years from Earth could ask a single question today and wait 2 full centuries for the earliest possible reply. In that gap, empires can rise and collapse, languages can drift until the original message only makes sense to historians, and an entire species could vanish before the conversation reaches its second sentence. A real exchange needs both civilizations to stay stable across timescales far longer than any human society has managed so far. That's a brutal synchronization problem, since Earth itself has existed for roughly 4.5 billion years, while our own radial bright phase has lasted barely more than a century. If some other civilization broadcasts for a similarly short window, the odds of their signal and ours ever overlapping shrink to something uncomfortably close to zero. They may have filled space with signals while Earth's oceans were still crawling with early animals, which means our descendants might not start listening until long after the last alien transmitter went dark. None of that erases the message itself, though. A signal keeps moving outward long after the civilization that sent it has disappeared. Electromagnetic waves don't switch off when their creators do, they simply keep expanding, like thin shells of information drifting through the dark. Earth could someday pass straight through one of those shells and pick up the final broadcast of a world that's been dead for millions of years. At the very same moment, an entirely different, living civilization could be transmitting signals that simply haven't reached us yet. So cosmic silence doesn't really prove that nobody has spoken. At most, it shows that no recognizable voice has reached the right instrument at the right second. And recognizing a real signal turns out to be its own separate challenge. Most searches assume alien technology will produce something our own instruments already know how to identify, which is exactly the assumption behind the modern search for extraterrestrial intelligence. That search effectively began in 1961, when the astronomer Frank Drake pointed a radio telescope at nearby stars and tried to put a number on how many broadcasting civilizations might exist across the galaxy. Radio seemed like the obvious channel, since humans already use it and it travels efficiently across interstellar distances, with unusually narrow frequency spikes standing out because nature rarely concentrates energy that precisely. Observatories built on that idea have to separate any promising blip from satellites, aircraft, human electronics, and ordinary cosmic noise, and a real detection has to reappear when scientists point the same telescope at the same target again. So far, every candidate that has passed that first test has failed the second one, which says nothing about whether a civilization actually occupies that system. Aliens might simply not communicate by radio at all. Their transmissions could be too weak, too brief, too tightly aimed at a single distant target, or sent on frequencies our instruments never check. A signal could sweep past Earth for 1 minute and vanish forever unless someone happened to be listening in exactly that direction at exactly that moment. Broadcasting continuously across an entire galaxy would demand a staggering amount of ongoing energy, and a genuinely advanced civilization might see little reason to keep shouting toward worlds it can't even confirm are inhabited. It might instead send a narrow, deliberate beam only toward planets it already suspects hold intelligent life. Earth itself has only revealed its technology recently, with our earliest radio leakage having reached a bubble of space roughly a century in radius. That sounds impressive, until it's measured against a galaxy about 100,000 light-years wide. Most of the Milky Way simply hasn't had time to learn that human radio technology exists. Even inside that small bubble, ordinary broadcasts fade fast as they spread, so the popular image of Earth glowing brightly with radio noise badly overstates how visible we really are. A recent comparison of different human technologies found their detectable range varying across 13 orders of magnitude, with powerful planetary radar standing out as by far our most visible signature from a distance. Cell towers, city lights, atmospheric pollution, satellites, and everyday radio leakage were all detectable across far shorter ranges, and most of Earth's strongest emissions are intermittent or aimed at specific patches of sky rather than broadcast everywhere at once. A nearby civilization could study our entire solar system carefully and still overlook humanity completely. Now flip that around, an alien civilization could be just as hard for us to detect, powerful on its own surface yet nearly invisible across interstellar distance. Efficient communication tends to leak far less energy than primitive communication. Human television once spilled broad signals straight into space, while modern networks increasingly route everything through cables, fiber optics, and tightly directed transmissions. A civilization's noisy radio phase might last only a few centuries before it moves on to methods we haven't invented yet or simply can't recognize. That world could remain inhabited, intelligent, and technologically advanced while looking, from our instruments, completely dark. Progress doesn't reliably make a civilization louder. Sometimes it makes a civilization quieter, blending its technology so smoothly into nature that a distant observer notices nothing unusual at all. That possibility has pushed researchers to search for broader technosignatures instead of waiting for a deliberate message. Industrial gases, artificial light, powerful lasers, unusual heat patterns, massive engineered structures, or objects moving in ways nature doesn't usually produce could all count as evidence. Each of those clues comes with real uncertainty, since natural processes can imitate surprisingly artificial-looking patterns, and a single strange molecule in a distant atmosphere isn't enough on its own to announce alien industry. Confirming life on another planet would likely take several independent signs, checked repeatedly and modeled carefully, because the universe is full of phenomena that look artificial right up until someone finally explains them. Suppose a genuine signal finally does arrive. It could still turn out to be meaningless, because communication needs shared structure, not just transmitted energy. Basic numbers and physical constants might offer a starting point, but anything more complex could be brutally hard to translate. Alien senses, bodies, environments, and entire evolutionary histories could shape forms of thought that have nothing in common with our own. A species that evolved beneath an ocean might understand pressure and vibration the way we understand light, while a mind shaped by a dense atmosphere could organize space, time, and motion around concepts humans have simply never needed. Their message might look like random noise to us, and our own careful reply could look exactly as meaningless to them. Intelligence doesn't guarantee a similar psychology, technology doesn't guarantee curiosity, and curiosity doesn't guarantee any desire to actually make contact. Some researchers have floated a colder explanation. Maybe advanced civilizations eventually learn that broadcasting your location carries risks nobody fully understands, and staying quiet becomes a deliberate survival strategy. That idea gets dramatized as a kind of dark cosmic forest, where every civilization hides quietly from every other one. Nothing currently proves hostile civilizations are actually lurking between the stars, so that darker version stays firmly in the realm of speculation rather than established science. A civilization doesn't need to be afraid to stay quiet, either. It could simply be indifferent, its attention turned inward toward virtual worlds, artificial minds, or problems we can't yet imagine. Humans assume expansion is the natural destiny of intelligence, mostly because expansion shapes so much of our own history, but another species might see endless growth as wasteful, dangerous, or simply pointless. A stable civilization could live contentedly inside a single star system for millions of years without ever building anything resembling an interstellar empire, and if enough societies make that choice, the galaxy could stay full of life without ever looking visibly transformed. Physical travel adds an entirely different layer of difficulty that science fiction usually glosses over. The nearest star system sits more than 4 light-years away, and even our fastest current probes would need thousands of years just to cross that distance. Carrying living passengers makes everything worse, since a ship has to protect them from radiation, equipment failure, collisions, isolation, and the slow breakdown of every closed biological system on board for the entire trip. Accelerating a large vessel to even a small fraction of light speed takes an enormous amount of energy, and slowing back down at the destination demands almost as much all over again, with ordinary dust grains turning into lethal projectiles at those speeds. Machines might survive that journey far more easily than biological bodies ever could. A self-replicating robotic probe could cross interstellar space, build copies of itself from local materials, and keep exploring long after the civilization that built it has died out. If machines like that are even possible, their apparent absence only deepens the mystery, though humanity has really only inspected a tiny portion of our own solar system closely enough to rule out something small hiding in plain sight. Space isn't empty in any simple sense. It's vast enough to hide almost anything, and an alien probe resting quietly on some distant asteroid could go unnoticed for centuries, its outline slowly worn down until it looks like ordinary rock. Technology fades fast once nobody is left to maintain it, with cities collapsing, metal corroding, satellites falling from orbit, and data quietly rotting away over time. On a geological timescale, even an entire planetary civilization might leave behind surprisingly little that another star system could recognize. Only the largest changes, like an altered atmosphere or objects locked into oddly stable orbits, are likely to outlive their builders. Searching for alien civilizations may end up looking less like first contact and more like cosmic archaeology, not living neighbors, but abandoned machines and chemical scars left behind in some planet's atmosphere. That possibility leads straight into the most unsettling explanation for the silence. Maybe technological civilizations simply don't tend to last very long. Intelligence hands a species enormous control over nature, but it also hands that species brand new ways to destroy itself, from engineered pathogens and unstable weapons to environmental collapse and conflict over resources. Nothing proves every technological species follows that path, but it remains one version of what researchers call the Great Filter, some extraordinarily difficult step standing between lifeless matter and a galaxy-spanning civilization. That filter might already sit behind us, hidden somewhere in the improbable origin of life itself, or the appearance of complex cells, in which case our own existence means we've already cleared the hardest barrier there is. A far more frightening version places the filter ahead of us instead, with civilizations repeatedly reaching our current level, gaining dangerous new power, and disappearing before they ever become visible across the galaxy. Under that version, every silent star out there would look less like an empty home and more like a quiet warning. Cosmic silence can't actually tell us which version is closer to the truth. Life might genuinely be rare, intelligence rarer still, and long-lived technological societies rarest of all. Or the galaxy could be full of civilizations that are simply quiet, distant, short-lived, or impossible for our instruments to recognize. Those explanations don't even have to compete with each other. A small number of civilizations could emerge across immense distances, each broadcasting only during its own brief technological phase. That alone would make direct contact wildly unlikely even inside a galaxy that isn't empty at all. The real mistake is picturing the galaxy as one crowded room full of people waiting to meet each other. It behaves more like an ocean scattered with islands that appear and vanish over billions of years. One signal fire burning for a single night on one island, another lit 10,000 years later, thousands of kilometers away. Both islands were inhabited the entire time. Neither castaway ever saw the other's flame. Our own search has barely started, which means the silence we've heard so far can't justify any real certainty about what does or doesn't exist beyond Earth. Better telescopes may eventually catch biosignatures hiding in alien atmospheres. Larger radio arrays may pick up weaker or more distant technological signals, and artificial intelligence may help scientists comb through datasets far too enormous for any human to check by hand. Even with all of that, no amount of better technology can force two civilizations to share the same narrow slice of cosmic time. No telescope can receive a transmission that was never aimed our way. No decoder can question a society that vanished before Earth even finished forming, and no spacecraft can casually cross a distance that light itself needs centuries to travel. Humanity might eventually prove that life exists somewhere else without ever actually speaking to another living mind. Finding oxygen produced by alien organisms, ruins built by engineers long gone, or a message still crossing space decades after its senders disappeared. A discovery like that would answer one enormous question, while quietly opening a sadder one. We'd finally know we were never truly alone, and that loneliness can still survive inside a living universe. Somewhere tonight, another species may be staring into its own sky, wondering exactly why nobody answers back. Its scientists might be listening on the wrong frequency. Its telescopes pointed towards some other star, its whole civilization sitting 5,000 years before ours, or 5,000 years after. The same galaxy could hold both of us without ever granting a single shared moment. One day, though, their very last message might finally begin its long crossing through the dark, arriving long after their oceans have dried up and their cities have disappeared, reaching a small world called Earth. We might understand every word of it and realize that another mind once looked up at its own sky and asked exactly the question we're asking right now. So we'd send our answer back across the stars anyway, watching it travel toward a planet where, by then, no one is left to hear it. Two civilizations, finding each other at last, only after it was already far too late.